In this slide deck, I'm going to talk about Active Directory replication. So replication is basically synchronizing all of the information in Active Directory amongst all of the Active Directory servers. So all the domain controllers should have the latest information. Active Directory is a distributed database, meaning there is no one single source of truth for a lot of the information in Active Directory. If you recall, there are five single sources of truth for things like the schema manager and the RID manager and the infrastructure management. Each of those can have a single source of truth for a variety of reasons. But usernames, passwords, group policies, a lot of things that we've talked about is distributed, and it has to be replicated. It's sort of this mesh of all these different servers that we have to replicate all this information in real time, or at least as close to real time as is feasible and is efficient. So Active Directory replication usually includes the following. It's going to be everything, all the information about objects like OUs, groups, computer accounts, and so forth. So all the things that we talked about in Unit 2, as well as changes to data held in partitions maintained by FSMO role holders, and trust relationships between different servers. Global catalog data. If you recall, the global catalog is sort of a subset of all of the information in the entire forest. That way, if you're trying to log in to a different domain in the same forest, that information can be accessed from the global catalog, but not everything will be in a global catalog, just a subset, enough for you to log in and enough for you to get a valid token. Group policy information, so all of the GPO objects that we talked about in Unit 2, all the files that are located in sysvol, such as the group policy templates and scripts and startup scripts, which are in sysvol. So intra-site and inter-site replication use the same basic process to replicate Active Directory data. Intra-site replication is basically replication that's happening within the same site. So it's assumed that it's a low latency, high speed local area network. Where intra-site replication is replication between different sites, where it's assumed that the speed between these networks might have a higher latency, it might be less speed, effectively. So replication can be initiated through notification, periodic replication every once in a while. Intrasite replication involves two main components: the knowledge consistency checker, or KCC, and connection objects. So the knowledge consistency checker is basically a process that runs on all of the domain controllers for intrasite replication. It builds a topology of all of the domain controllers in a site, and it establishes replication partners between those sites. So basically, the knowledge consistency checker's job is to understand the topology of the network in general, and come up with the most efficient, or maintain the most efficient path for replication between these different sites. And then once the replication happens, between sites, then the intrasite replication happens thereafter. So basically, KCC is going to recreate the topology every 15 minutes. So it's going to rebuild that topology, or its understanding of the topology. And the replication topology can be recalculated manually in Active Directory sites and services. So you can have it, you can manually kick off the process to have it to rebuild that topology. So this is an example of kind of what that topology could look like. It's going to basically figure out which domain controllers are going to partner with each other to pass through these replications and these updates between different servers. In other words, there's no one single server that hands out replication information to all the other servers. This all sort of happens dynamically in a mesh of servers that are all talking to one another. You can think of this as kind of how rumors spread, right? So, think about how a rumor spreads. One person finds some information about something, and they tell a couple of people, then they tell a couple more people, and before you know it, everybody knows about the rumor. So you can think of the knowledge consistency checker as sort of a really good, somebody who's really good at spreading rumors, more or less, which happens naturally in groups of people. But with computers, it's a little bit more complicated. So there has to be some algorithms that help define how that works. So connection objects define the connection parameters between two replication partners. So a change to an intrasite connection object is usually unnecessary, but you can do it manually in the Active Directory sites and services. The Active Directory sites and services properties dialog box, and those are the options that you will see that I'm showing on the slide deck. So you can create connection objects for intrasite replication if you want to alter the replication topology manually. right? So if KCC is not giving you the best the best and most efficient replication, you can manually override how that works. So some special replications procedure, you might have urgent replication events, such as where you want to trigger change notifications immediately, like account lockout or new account policies or passwords and things like that. So there are certain things that you need to push immediately, as well as user account password changes. If you change someone's password, they probably want to log in right away, so that might be the type of change that has to get pushed immediately. So when you make a change to a password, that might replicate immediately rather than waiting for the next replication, regardless of the site link. You can check the replication status. So in Active Directory sites and services, you can force the KCC to check the replication topology with the repadmin.exe tool. You can use repadmin can also be used to show the partitions being replicated by each connection object. I will give you a little bit of advice here that if you are going to sit for any of the Microsoft exams, it's a good idea to memorize these commands because they tend to ask about a lot of these commands and what they do. So inter-site replication is replication that's happening between bridgehead servers, right? So these are which we just talked about when we discussed sites. So this is replication happening between the bridgeheads, which are our designated intermediaries for all the replication between two different sites. So when the knowledge consistency checker detects that replication is going to occur between sites, one domain controller on each site is designated as the inter-site topology generator. In other words, one server is going to basically be in charge of coming up with that, with that topology for doing the replication. So usually it'll assign a bridgehead server for each directory partition in the site, but you can also assign a bridgehead server manually. So you don't necessarily have to define a bridgehead server, but a lot of times it's good to have the control and to know which server is the bridgehead. Although if that bridgehead goes offline, then typically the KCC will assign a different server as the bridgehead. And once again, you can use that repadmin tool to look at the bridgehead. So if you want to see what the bridgehead servers are, you can use that repadmin tool. So the repadmin/bridgeheads, and again, it's probably a good idea to make sure you remember some of these commands because they come up in tests a lot. But in any event, the designated preferred bridgehead server in AD sites and services, you can find the server in the servers folder under site, and then right-click on a server object and click properties. And then you can select the inter-site transport protocol on the left and add it to the server as the preferred bridgehead server in the list box. So as far as, and by the way, this is what the properties dialog box looks like. Now, as far as the protocol for doing replication between two different sites, there's two options really. One is IP, which is the way we would do it intra-site as well. So that doesn't really change anything. It's the same method. But if you have a particularly slow or unreliable link between two sites, you can also use SMTP. I don't really see this implemented very often, but it is an option using SMTP. I guess back in the old days when we had really, high latency networks or T1 lines that were not very fast, it made a lot more sense to do this. But basically, you're using email to carry the replication information between servers. You're using the SMT protocol, essentially. It's not necessarily email in the sense that it's one server sending an email to the other. You're just using the SMTP protocol as the method of moving that information just like you would with an email, where you do a call to an SMTP server and you send the payload through SMTP, and then the other server, receives that information. But there's no, email address that you're sending that information to in the sense that you would with SMTP as an email protocol. So requirements for the bridgehead servers on both ends of an SMTP configured link site. You have to have SMT feature installed on both servers, so they have to have the SMTP. There is an SMTP service or role that you have to install on the server itself. It's just a standard Windows server role. You have to have an enterprise certification authority on the network, which we're going to talk about in a few weeks. We'll talk more about certification servers or certificate servers. The site link path must have a lower cost than an RPC over IP site link. By the way, when we use IP, it's RPC really that it's using, or remote procedure call. And domain controllers must be configured to receive email. So they have to be able to receive that email with SMTP. So site-link bridges, by default, a site-link bridging is enabled, which makes site links transitive. What we mean by transitive here is that they can change dynamically, right? So, but you can change that transitive behavior of site links by turning off the site-link bridging and creating your bridges manually. So again, you can let Active Directory and the knowledge consistency checker automatically create these links through its topology generation, or you can manually set this. Some of the reasons you might want to do this manually is to control traffic through firewalls, to accommodate partially routed networks, reduce confusion of the consistency knowledge checker. For example, here's an example where we have two sites, and we can manually configure the replication through through certain domain controllers at each of these sites. We can manually build this topology. We don't have to let Microsoft Windows KCC try to figure that out on its own, which may or may not be correct. So a read-only domain controller is basically a domain controller that receives updates but never sends updates. So it can receive an update, it can receive replication information, but it never actually sends those. So you can't, for example, change your password using a read-only domain controller and expect that to replicate. In fact, something like that would require a domain controller that's not read-only. So it's a unidirectional replication. It's only replicating to the read-only. RODCs can replicate only Windows Server 2008 and later writable domain controllers. So the advantage of using them is you can limit which accounts passwords are replicated to an RODC, say at a remote office, for example. All right, so a read-only domain controller placement must ensure the replication occurs between an RODC and a writable domain controller. So a writable DC is usually placed in the site nearest the read-only domain controller site. And when we say nearest, we're not talking about nearest geographically, but nearest as far as the site link, the speed of the site link. So whatever is the fastest connection, which may not necessarily be the closest geographically. If this placement is impossible, you have to create a site link bridge between the read-only domain controller site and the site with the writable domain controller. So you have to manually create that link to tell it what is the fastest connection to do those replications. Account passwords are not stored on read-only domain controllers, which kind of makes sense because if you try to change a password, it'll never replicate off of the read-only domain controller. So to prevent this, you can specify accounts for which passwords are replicated on read-only domain controllers. And here's our password replication policy dialog box, which you're going to see in actually one of the labs. You'll be taking a look at that. Sysvol has some information. Sysvol, we've mentioned it a few times. This is where things like group policy and the group policy template files and the component files and also the script files, the startup scripts and things like that are all stored in Sysvol. So this also has to be replicated. So the group policy template files, the ADMX central store, which has your group policy settings and logon scripts. And typically this is going to happen with the distributed file system or DFSR. We haven't talked about file systems yet, but later on in the course we're going to talk about the different types of file systems and network file systems that are used by Microsoft Windows. And one of them is the distributed file system. And this is the mechanism that is used in 2008 and later for replication, for replicating these files. So when you make a change to a file in Sysvol, Active Directory is not really doing that replication natively. It's using the distributed file system to do that, and it's DFSR. And it's a little bit more reliable than the older method, which we talked about previously when we looked at sites. So a group policy object has two components, which we learned about previously. We learned about the group policy template, which actually contains all the settings, and then the group policy container, which has some of the metadata about the group policy. So they are replicated during normal AD replication. And again, it can either be through file replication services if you're running Windows Server 2003 or 2000, and through distributed file system replication or DFSR if you're running Windows Server 2008 or later. That's not to say that if you're running 2008 or later that you can't use FRS, but it's a good idea if everything is on 2008 or later to switch to DFSR. It's going to be a little bit more reliable. So because GPC and GPT use different replication methods, they can periodically go out of sync, right? So they, the mechanism that does a replication, and remember, it's the combination of the GPC and the GPT that makes up the group policy. So if they're not synchronized, you may have, some issues with group policy. That usually occurs when you have lots of different sites with slow WAN links and things like that. And typically it's just because the updates for the one that's out of sync just haven't arrived yet. But once they do arrive, then the issue will go away. But you can also diagnose some of these problems using the Group Policy Management Console, which we looked at in Unit 2. And here's what it looks like again. So as I said before, if you're using DSR, you're going to want to upgrade to DFSR. And the reason you would be on DSR is because you at one point had your domain or your forest or either one of your domains was running server 2003. But once everything's on 2008 or newer, you can upgrade to DFSR, which is going to be a little bit more reliable. So you're going to want to migrate to the more reliable standard as soon as you have all of your servers on 2008 or newer. Before you migrate from FRS to DFSR, you have to understand the migration states, which are listed here and are discussed in more detail in your textbook. So migrating is done with the DFSR migration command or DFSR mig command on a writable domain controller, right? You don't want to run that from a read-only domain controller. So before you begin, you do a system state backup on the domain controllers using this command, and then you follow the steps to do the FRS to DFSR migration, which are, by the way, they are outlined in the text if you're curious how to do that. I didn't want to bore you with the details here in the slide deck. As far as managing replication, so once replication is, replication should pretty much manage itself, but you may have to manage it. So the rep-admin command has some options in it that will help you check the status of replication, do some replication troubleshooting, and also to manually trigger replication if it's needed, or look at the topology, for example. We talked about KCC and how it creates that replication topology. So there's a command line switch that you can use to evaluate that as well. You can use AD sites and services to force replication, and you can also use KCC to check the replication topology right in the Active Directory control panels. You can monitor replication with the rep-admin command as well. You can use DC-diag to analyze the status and overall health of Active Directory, and it performs replication security checks and checks for correct DNS configuration. So that's another useful command. Again, it's a good idea to look at these commands and have a good understanding of, and here's a list of some of the PowerShell commands as well, but I would say it's more important to make sure you know these basic commands because it's a good chance that you'll see those on a test, and it might ask you to describe what each of these different commands does. But these are the PowerShell commandlets that you can also use to do some of the same things that we looked at here. And that's pretty much it for this unit. So we talked about how to configure sites and site links and understanding how replication happens between these different sites. But also we got a basic understanding of the replication process and how replication works in general with Active Directory. And that concludes Unit 3.